These are the solutions to CYU 13, which was sort of a mini study guide, just some practice problems from the unit. So the first ones here, these are from target A. And so what you're needing to do is make a sketch. We've got a right triangle, and the string to the kite is the hypotenuse here. And what's happening in this is that he's holding the kite string, and that is 2 feet off the ground. So there's this bit underneath the triangle there that is 2 feet. The angle of elevation, which is going to come up from the ground here, that's that 36 degrees. And the length of the string, which is the hypotenuse, that is 16. And the question is, how high is the kite off the ground? So that's this portion of the right triangle. And when we are all done, we are going to add the 2 to that value that we find for x. This is the opposite, and this is the hypotenuse. So we are doing opposite over hypotenuse. So that is sine of 36 equals x over 16. We can cross multiply, and here we are going to get 9.4 for the value of x, right? That's this value. And we also need to include the height, which is from his hand down to the ground. So the total overall height of the kite is 11.4 feet. For the second problem, Charlotte is standing on a 25-foot tall balcony. So she's standing on the top of our balcony here. And there is a rope that goes from her feet over here to the ground, staked into the ground. The angle formed between the top of the tower and the rope. So now we are looking up here. That's the top of the tower and the rope. That's a 70-degree angle. And the question is, how far away from the base does the rope reach? So that's this distance. And we have a 25-foot tall balcony. So what we're looking at for this is we have our theta here. This is the opposite. This is the adjacent. So we are using tangent. Tangent of 70 equals opposite over adjacent. Again, we can cross multiply here, and we are going to get 68.7 feet. That is the distance down here for the rope, how far away that is. All right, then we are going all the way to target D and practicing some of the graphing that we've been working on. So we're going to take this plus 3, and we're going to shift our graph 3 units up. So this is where our new midline is. Then we are going to pay attention to the fact that this is a reflection. So we're taking sine and reflecting that. So I'm going to I'll start with that reflection. There's no amplitude change. So a reflection for sine would look like this. Goes down instead of up, back to the midline. Now we're going up and back to the midline. So that is this and this. That's what we've taken care of. The next part that I want to pay attention to is that I'm shifting this entire graph now to the right, pi over 2. So every single point is going to be shifted to the right. So this point here, right here at the 3, this is going to go over to the right here. This point down is going to go to the right. This point is going to go to the right. So every point here is going 1 box over, because that's where pi over 2 is. So I'm here and here. And so when we sketch this now in red, you'll see that that is that same as the green, but we have scooted that over pi over 2 to the right. All right, so let's take a look at this one. This one's a cosine graph, and we are down 1, so our midline is down here. That takes care of this. We also have an amplitude of 4, so we're going to be changing that to be 4 units tall. So I'll start with that. Cosine typically is going to be 1 box above the midline, but because we have an amplitude of 4, we are going 1, 2, 3, 4 boxes above that midline. Back to the line. Now we're going to go 4 boxes below, back to the line, and we're going to go 4 boxes above. So this is what that would look like if we just paid attention to the K and the A values. That's the amplitude here and shifting down 1. What this does is this changes the period or the frequency of the graph. So we're going to do 2 pi over that b value. That's that b value. And this tells us now that the period of this graph is pi. So all of this green graph that you see here is going to happen now. Instead of taking up 2 pi for that to happen, this is going to, now all of this is going to just happen in this space. So that entire graph is being compressed. So what's happening is it's going to be finishing, I'll use a different pen here, sorry. It's going to be finishing up at pi. Still starting here. Halfway between those, it's going to be at the bottom. And so this is going to go like this. And then it would just continue to repeat. So it would do 2 of these in that same span that we did the original green graph. So that's what one period would look like. And of course, we know that this is just going to continue. All right, so let's take a look here. Here we're going back to target C with the unit circle, and we're making some sketches. 240 is going to be in this quadrant here because this is 270, right? This is 240, and this is 180. So our unit, or our reference triangle here, it goes up to the x-axis. This difference between 240 and 180, this is 60 degrees. So we have a little 30 down there. Okay, this is there's our angle, right? So if I'm labeling the sides of this triangle, across from the 30 is the 1/2. This is the radical 3/2. So this point, if we are looking at coordinates, because we are going to the left and down, our coordinates there would be negative 1/2 and negative radical 3/2. And for sine, I'm always going to be looking at the y value. So this is my y value. And so my solution here is going to be negative radical 3/2. Next is tangent of 3 pi over 2. That one is on the y-axis. 3 pi over 2 is down here. And that point is at 0, -1. Remember that tangent is y over x. So we want to put the y over the x. So we want to have -1 over 0, otherwise known as undefined. All right, and then lastly, we are back to the graph again here. We're writing a sine function. So I'm going to use sine that has a vertical stretch of 3. That is our a value. It is shifted up 2 units. That is our k value. And it has a period of 4 pi. So that is not the b, but b helps us to get there. So if we have 2 pi over whatever b is supposed to equal, we know that that equals 4 pi. So you can kind of think it through like, what do I have to divide here so that I get an answer of 4? Or you can do a little cross multiplication. And so if I cross multiply this, I have 2 pi. And if I do this, I have 4 pi times b. And I want to figure out what b is. So that's what I'm going to be dividing here by this whole 4 pi. And 2 over 4 is just 1/2. So the value of b is 1/2. That says that when I do 2 pi, and I divide that by, if this b value here were 1/2, that is how I would be getting a 4 pi as my solution. So I'm going to use my a value of 3. It's a sine curve. The b value is 1/2. That's what goes in front of your x. And then you are adding, because we're going up here, so we're adding the 2 at the end. So that would be our equation that matches that description. All right, so that is the end of CYU 13.